Welcome everybody, and thanks for joining us today in this webinar. We are going to talk to you about the multi-DC CO2 solution, that it's one of our most innovative products and that we are kind of proud, we can say.
Yeah, I think so.
So I'm here with my colleague, Matteo Del Corso. I'm Federico Ferrari, and we work together in CAREL's marketing unit regarding food retail solution for refrigeration. I think we can start because...
I think so. These are our contacts.
Yeah.
Just to complete what Federico said, we are working mainly on compressor racks and condensing unit side. So we are following this kind of application that you can use to set up a compressor rack or, of course, a condensing unit. Please, Federico.
Yeah. And as you see, the rack is only one of the products of the wide CAREL portfolio, together with cabinets, components for food service, IoT services, and so on. And today, as I mentioned, we are going to talk to you about one of our solutions for CO2 racks. So let's take a step back and start with an overview of the current scenario for food retail refrigeration. So I will ask Matteo, can you give us an introduction, an overview of what's the situation?
Sure. Let's say that in the last, I would say 5, 6 years, we have seen a big trend for CO2 applications in refrigeration. This was mainly focused for big compressor racks at the beginning. So even because at the beginning of the CO2 refrigeration, the extra costs, it is more easy to let's say to hide some extra cost in a big unit. But year by year, this kind of CO2 application in refrigeration, in food retail refrigeration, I mean supermarket or let's say C-stores or food stores in general, are growing faster. And we were able also to optimize the cost of the components, but also the cost of the full unit. We have seen in the last 2 years, 2-3 years, a very big trend for small and medium unit. You can see on the right of the slide, there is the EQ CO2 application, that is an application for condensing unit. But if you want to increase the cooling capacity of this condensing unit, of course, it's necessary to put in parallel more than one compressor. I mean, this kind of compressor, so DC inverter compressors. And this is bringing us to speak about the multi-DC solution. So if you want to give more details to the people attending.
Yes, thanks for this overview. So just to summarize, from big racks that actually we still support and produce with P-rack, our main controller, and now with mass production, a smaller unit like EQ and PR multi-DC. And that's what we are going to talk today, the PR multi-DC. This solution put together quite a lot of CAREL's best technologies, like the DC compressor and the XV electronic expansion valve. In this solution, that you can see an example in the slide, we have a rack that supports up to 4 DC compressor in parallel for the medium temperature line, providing up to 35 kilowatt, together with up to 2 compressor for the low temperature line, providing up to 10 kilowatt. Using only DC rotary compressor means that we can reach a very high modulation. So we can go from 5 to 100% of the rated capacity of the unit. And also we can keep a very high efficiency since we follow the load in each conditions. Since it's a very small unit, also one of the main benefits is its compact dimension. And it's a very good choice to replace outdated HFC old racks. So this is just an overview. Let's get a bit in the details of the function of this solution that in the end is the fruit of a wide experience of CAREL with the CO2 that's been in the last years. We made a lot of experience, and in this controller you can see a lot of these results. For example, about the CO2 management with the optimal high pressure for the gas cooler, of course together with the flash gas, and then other benefits for the circuit and the compressor. Since it's a complete solution, and in this circuit you can see all the components we provide to put together this solution, and it goes from the electronic controllers to the controller at the cabinets to the valve. And something that I invite you to notice is the magnificent length that indicates the big news that we are going to present today. That is the oil management system. And there is a proper valve to do that, but we are going to get into details in a while. Continuing with the function, of course, there is also the ease of use guaranteed by the PRAC. That it's our, I will say, consolidated product because it has a long history.
Standard product with a very long history. Yeah, more than 10 years, we can say.
Yeah, so yeah, it's been evolved continuously and kept improved. All of this, it's possible to supervise all of this with the RED cloud system. That it's our supervisory system that works with BOSS. That it's our supervisory local system to get an overview of what's going on from each plant and each supermarket. Going from the function, let's see so the material that we provide as CAREL. For this solution, we can say one-stop shop. Your main provider of all these components, since we go from the controller that we mentioned before to the compressor. We developed together with Toshiba an exclusive design for this rack. You can see here the rotary compressor. Then there are the electronic valves, the cabinet controllers, and the supervisor that I mentioned before. These, together with the probes, can be fitted also in an additional service, because something that we saw, it's been very appreciated from our customer to provide a complete solution with the electrical panel made here in our headquarters.
Yeah, maybe let's make a step back, because you said that we can provide also an electrical panel that you can see on the right of the bottom right of the presentation of the slide. Maybe our attendance doesn't know that CAREL, at the beginning of his business, it was a panel manufacturer. So the first business for CAREL was making electrical panels. So we were and we are expert on doing that. But year by year, we increase our product portfolio with, of course, controllers. That was the main success of the company. Then valves, drivers, and one of the last innovation was the ejector for CO2 applications.
Yeah, that's probably something interesting for our viewer and our customer, because probably not everybody knows this story. But yeah, this is CAREL history. But let's go to the core of this solution. We say that this rack is a multi-DC, but what does it mean? We use exclusively DC rotary compressor. And this choice, of course, has some strong point behind this. For start, DC rotary compressor let us do a modulation that it's not possible to do with a normal AC compressor, where the capacity is modulated by varying the frequency of the compressor. So in this case, the compressor with a permanent magnet can go from 25 to 100% of its maximum capacity. And you can imagine that combining up to 4 of this compressor improve even more this modulation range. Other advantages is that we pilot this compressor with not a simple inverter, but with a proper driver. That means that we have the experience made in our lab to provide every compressor with their optimal electrical parameters. And with this driver, we provide an additional safety and security. You can see in this animation where there is the circuit of the multi-DC. What does the driver do in the end? So it keeps the compressor in the perfect envelope condition, keeping it safe in its design working conditions. Also, this, since it's rated with Class B software safety, it's possible to save some money in the end with not putting some additional safety electronics. So all this modulation has an impact on the consumption for the final end user. So Matteo, will you tell us something about this energy saving, please?
Yeah, sure. This was the data that you can see on the screen. The energy saving data that you can see are coming from a real case study from some installations that we have in Poland with several multi-DC units. So these kind of units, the multi-DC version, were compared to some traditional units with pistons compressors and AC inverter. Of course, the main difference between these two units is the type of compressors, because the BLDC are a little bit smaller, so we need 3 or 4 of them. And in case of pistons compressor, two pistons compressors are enough. But of course, only one of these two is driven by an AC inverter. So this is the main difference. We saw that we can get an energy saving that is between 10 to 15% compared to these units equipped with pistons compressors. And this is due especially at a sort of average load, so medium load of the unit, because when a pistons compressor unit with 2 compressors is working at very low load, there is just one piston compressor on that is modulating with its own AC inverter. And of course, at the same time, when it is at full load, you have the on-off that is on, and the other with the AC inverter that is modulating. But at partial load, the multi-DC unit with DC inverter compressor have a big advantage because we have a wider range of modulation, and while the pistons compressor unit is modulating with the AC inverter and the other one is going on and off, the multi-DC unit can better keep the load, modulate, and be more stable and save energy. And this is the result. So it is a nice result to be able to save from 10 to 15% of energy in 1 year.
Okay, yeah, the smooth transition, I think it's pretty obvious. You can see this very smooth line in the regulation in the graph that you can see in the slide. So we are talking about a continuous modulation with no on-off cycles. But of course, this continuous modulation brings some delicate management of the oil, because instead of having a compressor that is running at a constant speed, you have some jump in speed, some continuous
and also
change.
very low speed, because these kind of compressors can modulate between 25 RPS to 100 RPS, but at 25 RPS, the speed is really low compared to other technologies.
So this is something that we had to face to make this product reliable, and we want to assure. So quite a lot of tests have been made in the R&D lab of CAREL. And the result was a very interesting solution for oil management that take advantage of a valve connected to our compressor that have been made specifically for this purpose. So you can even see here the compressor. There is at the proper level a balance pipe that it's put exactly at the optimal oil level that we want to keep in the compressor crankcase. With this, there is a connected valve where we, through a specific software logic, we expand every given time the content of this high pressure crankcase that goes through the valve and tell us if there is oil or not. Matteo, there is a patent behind this, correct?
Yeah, all the projects started, as you said, in order to make this kind of technology easier to be used by our customers. We did several things, several tests, but we did also a paper, so a scientific paper that was presented in ORID, an important conference that is speaking about natural refrigerants a couple of years ago. And there is, of course, a paper and also a patent connected to this logic and to this kind of technology that we are using to check if there is oil or not inside the compressors. Of course, there was also a big and long job on our laboratory, on our R&D side, to test and fine-tune the solution for our customer. That is why we are launching the solutions after, we can say, 1.5 years of tests.
Perfect. We can get into details of this logic that commands this oil management system. That's part of our electronic controller, the PR multi-DC controller. In this GIF, maybe it's kind of complicated, but let's check the various phases. As I mentioned, after a given time, the valve opens and the refrigerant inside the compressor flow through it. Here we can have two cases. If there is no temperature difference at the inlet and the outlet of the valve, it means that some oil is flowing, meaning that the oil level is optimal or at least above the minimum level. Instead, if we notice a temperature drop, it means that some refrigerant is expanding in the valve, causing a drop in temperature that we measure. And in that case, we can do two things. First of all, we keep the valve open for a while if a compressor is lacking oil, to let the compressor equalize between themselves. We have a line with maybe up to 4 compressors for MT, up to 2 for LT. There is the chance that they equalize themselves automatically without adding additional oil. If this is not sufficient, because maybe all of them were running slow for quite a bit of time, we can inject oil, and then we can do another test that hopefully it will be enough to make them run correctly. So these are the two main conditions that we are looking for. And in the end, the system is able to provide by itself to the optimal oil level. I would say that at this time we can summarize a little bit the offer to our customer to make a clear idea of what they can expect from this unit. So Matteo, would you like to explain the main benefit of multi-DC as a solution for OEM, but also for retailer that want to apply them?
For sure. Let's say we had the possibility to see from a technical point of view the solution, but if we want to summarize the benefits, these are, of course, the very low noise compared to standard technology that this kind of compressor can give to your unit. So the unit could be very silent compared to other technologies. Another possibility is the very compact design. So in this picture, you can see, I would say also a common design, because more than one manufacturer is using this kind of case. The main benefit is that it stays on a Euro pallet, and its height is around 2 meters. So it is easy to install inside or outside, to find some space outside or inside the supermarket. And this make this kind of solution very good for urban context. So I mean downtown, city center, when there are big limitations in terms of space, but also in terms of noise. So you can imagine if you have a proximity store in the supermarket in the city center, where you need to keep attention to the noise and to the house of other people that are for sure close to the supermarket. And this make also this unit very good for retrofits. So if you want to change an old HFC unit with this one, this is a perfect solution because it is very compact, easy to run, and can bring also some energy saving to your electrical bill.
Regarding this last point, we can say that our customer showed to quite like these features because, as you well explained, this well-fitting for retrofits has been appreciated for some retailer that decided to make some wide campaign for retrofits,
yeah,
to jump in the present, or we can say even in the future, with a future-proof solution that it's efficient and at the same time green with the
yeah,
natural refrigerant. With
this is bringing us again to Poland, where this retailer 2 years ago got the award for its campaign of retrofits to of course improve the energy efficiency, but also to reduce the impact of CO2 on the environment. So it was a very good, very nice success for CAREL, and of course for the end user that was using this solution.
Perfect. Okay, I think we cover the main benefits, and at this point we can say that we are fully ready to support our customers, the OEM, to design this solution. You see here what we can provide as a documentation, as a calculus system, compressor specification, application manuals, and also some more commercial brochure that you can download from our website that I invite you to discover. It's natref.carel.com with a specific part for multi-DC. And here you can see all CAREL portfolio for natural refrigerant, not only multi-DC, but also, for example, our ejectors and other solutions that use only natural refrigerants. I think we said a lot of stuff. Let's see if our viewer have some questions or want to go deeper into some topics that we maybe were quite fast to present.
I will put also this question on the chat. So
if you have any question,
any
feel
questions,
free.
We can see from our tablet, and we can answer directly to you. Maybe in the meantime, the people can write, can put some question to us. Maybe you can tell them some more information about that specific range of compressor that we developed.
Yeah, sure. Maybe we were fast in that part, but let me go back to the DC technology. That it's yeah, in just a few minutes it's hard to explain all the benefits, but what you were saying, Matteo, it's about the modulation range. So with DC rotary compressor with permanent magnet, it's possible to achieve a much wider modulation of the system. And that means in the end to being able to cover not just the design load, but also the partial load. And from the data of the field, we saw that in the end, it's the majority of time that a machine runs.
Working at partial load for sure. Yeah.
So that's the part where it's important to, well, for a start, to being able to reach this partial load, but also to reach this partial load with some efficient. And you see the comparison in this graph with the two curves, where there is the fixed speed compressor efficiency compared to the DC inverter. And at partial load, the DC inverter showed all is potential.
Good, good. Let me complete with another thing. I was looking to the tablet, so I don't know if you said this thing, but we have a full range of compressors. We have
sure.
4 models, vertical models, and we have also 4 horizontal models for other applications where it is necessary to save some space, especially in heat. In the meantime, we got a question from an attendee. And he's asking us if we can show again the oil system. So how
sure.
the system works to check the oil and refill in case it is needed. So if you can go in that slide.
Let me go.
Let me say one thing before Federico. This GIF is also available in our website, natref.carel.com/multidc. So if you want to take your time and look to this logic, you can find all the information there. But maybe we can make, we have quite a lot of time, so we can make a recap of this.
Yeah, exactly. Maybe you can explain better something that was very fast at the beginning. So here, the GIF represents, of course, just 2 compressors, but the line can be, as we said, up to 4 compressors in parallel. You see also the perfect oil level showed with the white line. And the balance pipe keep just that perfect oil level. All these compressors are connected between them with this balance pipe line that goes directly in the compressor suction. So there is a recirculation where the oil, if there is more oil than enough, it can go back to the suction and be redistributed to the compressor that maybe are lacking.
Sure. Maybe an important detail. Why we are doing this oil balancing procedure by opening the valves. This is because sometimes the oil level inside the compressors, even if they are running at the same speed, but of course due to some on and off of some compressor of the rack, because we have a very low partial load if we want, there is the possibility that the oil inside the compressors is not the same. So the first thing that we try is to open all the valves and try to put all the compressor at the same oil level. Then we make another oil check procedure, and if they are still missing oil, we open the dedicated solenoid for the oil refill, so this one. I don't know if you were completing.
Of course, you well said that it's about the piping distribution, and this is a very critical step. We support our customer, providing some consultancy if needed to provide the best pipe design, because in this case, it must guarantee that every compressor is the same distance, for example. It must be designed with some with some attention.
Yeah, we are having also another question. If we consider to recommend a filter in front of the oil return valve, because of course the orifice is very small. We didn't say that, but this valve. I don't know if you are familiar with the electronic expansion valve made by CAREL. The models start from 0, 3, and then they increase according to the orifice. But this valve for the oil management are the E2V01. So it is the smallest orifice that CAREL was able to do. And we design a so small valve in order to reduce the efficiency losses, because when we are making the oil check procedure, at the end
it's like a bypass.
Yeah, we are bypassing some oil or refrigerant, so it is a loss of energy. The only thing that we can do is to keep this loss as small as possible. Coming to the specific question, these valves have a specific filter. I do not remember the mesh in detail. If I remember correctly, it should be 400 or 500 micrometer, but I would like to be more precise, so I will send a mail to the person that is asking this question. And we don't have a specific recommendation to put a filter before the valve.
I would say that, sorry if I interrupt you, but I would say that from our experience, we saw that with a proper piping, soldering, and a proper build of the machine, we never faced problem with these kind of issues, I would say.
I would maybe prefer to have a filter before into the suction, and maybe in other points of the circuit according to the standard criticity of CO2 applications. But I would not recommend a specific filter before the valve, also because it could be an additional loss for the system. So if as Federico said, the circuit is designed properly, if the soldering were made well, with a filter at the suction inlet, it should be enough. Oh, we have also a comment from the same person. He said that they have mounted a 200 micron filter and it is running perfect. And for us, it's totally fine. So you decided to take this additional safety, and this is good for sure. So if it is working perfectly, why not? This, let me check if we have other questions. I don't see any other questions coming.
Meanwhile, feel free to contact us also after this presentation. You saw our contacts. I will put them back. I will show back our contacts mail, so you can write us if you have a further question, or if you want to get in contact with us, and we can talk about this opportunity.
Good. Some people, I can see also some people are going to leave. Of course, if you have any other questions, we have other 5 minutes, so we can stay online a little bit more. I don't know if we have the possibility to speak about the difference between AC inverter technology and DC inverter technology. This is maybe something interesting for the people that are still in the room. Let's say that they are two different technologies. I would like to use very simple words. Maybe they are not perfect from a technical point of view, but will help our attendees to better understand. The AC inverter is a device that is modulating the frequency of the voltage that we are giving, input voltage and current that we are giving to the motor of the compressor. The DC inverter technology is a little bit different, because it is developed just for compressor that use brushless motors with permanent magnets. And what the DC inverter is doing is creating into the stator a rotating magnet field that is actually bringing the rotor to the rotating movement. So we are not modulating the wave of the current of the voltage, but we are creating a rotating magnet field that is actually bringing together the rotor. So it is a completely different concept compared to traditional technologies, and it is also the only way that we can use to work with the brushless compressors with permanent magnets. Let me check again the chat. Okay, I think there are no additional questions, and also some participants are going out. So,
what can we say? Thanks for joining us today in this webinar, and we invite you to check also the other events. For example, later on there will be another webinar about chill booster, so another solution for compressor racks. And enjoy the fair, the virtual fair. Yeah. It's a strange event, but
and come to visit us to our virtual booth, and feel free to make questions.
Yeah, exactly. You can contact
every kind of things that you want to ask.
Thank you.
Thank you very much. Bye.
Bye bye.
Bye bye.